So hi everyone, thanks for taking time out today to be here. So we have Jillian with us here today. Jillian is a statistics and CSE PhD student at the University of Washington. So she primarily works on AI alignment, safety, and impact. She's advised by Yejin Choi and Thomas Richardson, and her focus has primarily been on projects which leverage statistical tools to advance methods and insights in human-centric NLP challenges. So currently her work centers on alignment, controllable generations, and impact of AI on society. Today she's here with us to present her work on how biased AI can influence decision making and what we can do about it. And this talk will be followed by a Q&A session, and Vin will also be hosting a discussion with Jillian, and she'll be talking about her research experiences. Yeah, so take it away, Jillian.
Awesome. I'm so excited to be here, especially with such an international group. I'm really excited to present my work about the power of bias and how biased AI influences our political decision-making and what we can do about it. If at any point you have a clarification question or a quick question, feel free to either chime in. I guess on the chat is probably best. I'll have it up, so hopefully I'll be able to catch you. If not, at the end, you can always ask questions as well. All right, so I'm going to start with a statement that AI language models are biased, and this has been shown in the past couple of years in the research in many different forms. So we've seen it with political bias, social bias, and we've seen it in all parts of language models, in the training data, to the embedding space, to the output that it's generating. But in more recent years, we've also seen its downstream effect from when we start using these language models in tools that we're using in everyday life. So if you're using it for a tool for hiring, or maybe an artistic algorithm, or even in the AI medicine space, we're seeing its downstream effects more and more. So we know that AI language models are biased, and we're using them more and more in our everyday life. So the question that me and my collaborators wanted to research was, how is it affecting us? Specifically, do these interactions with these biased language models affect humans? And if so, how? So that's going to be the main idea of the talk today. I'm going to go through our motivations for our research, talk about the experimental design that we implemented and the results that came from it, then also kind of have a broader conversation about what's currently being done and where I think there's some gaps or holes for new research to be done. And then we'll conclude it all at the end, and again, happy to take questions. So what is the motivation? Why do we think that this biased language model would even have an impact on humans? Well, it comes from a long history of research in both psychology and sociology, political science, that interaction with biases in traditional forms does seem to have an impact on humans. This has been seen with biased individuals, print media, and also other political news outlets. So things like online or with television, when you interact with these, it's been shown over and over again that it does impact your decision-making. But the question that was remaining, that more related to our field, is would the biased AI impact you differently? So we do know that it is different from individuals or print media, and will it have a similar effect? So this was kind of the question we wanted to research, and there was some past research in this area. And it generally falls into two veins of research in the past. So first and foremost is this idea of trusting AI. And so there's a lot of information, or there's a lot of research that looks at this. And the general flavor of these types of experiments is you give information that you say comes from an AI, and you give that same information and you say it comes from a human or an expert, and then you ask the individual to make decisions or learn a skill, interact with that information somehow, and then compare and contrast if you said it was from an AI or if you said it was from a human, and it kind of gets to this trust aspect. Some challenges with this type of research is that it tends to be static conversations, so you don't have this interaction. You're just given the information and told it's from an AI. And also, they tend to be fictional or impersonal tasks. So you might be asking to make a hiring decision, but you're not actually the manager. You're not actually going to have to manage that person. Or you might be asked to learn a medical skill like medical classification, but again, you're maybe not even a medical professional. Another more recent type of research that has come out is looking at interactions with AI and how it changes our behavior. This has mostly been done with AI-generated auto-completions. So you would ask a participant, write a paragraph about your thoughts on if social media is important for society. And they'll start writing their thoughts, and when they pause, they would then have an AI-generated auto-completion that they can choose to accept or not. And unbeknownst to them, that auto-completion might be biased one way or the other. And then they would kind of compare whether you had the biased or the non-biased and how your responses compared. So this has been done a few times, and there are mixed results, some showing that there is impact on humans and some showing that it's not. But you only have this one-sided interaction. The auto-completion gives you a suggestion, and you can either say, I accept or I deny. So for our experimentation, we wanted to focus on a few new characteristics. We wanted it to have this two-way interactive effect. So we wanted you to be able to ask follow-up questions and really interact with the AI. We wanted it to be in a more common setting, something like a chat box that people are using and understand our AI. And then we also wanted it to be personal tasks. So we wanted the decisions and opinions that we were looking at to be really affecting the individual. Okay, so that was the motivation for our experimentation, but now let's talk about how we actually created that design. And I will say that creating a design around any human experimentation is probably one of the hardest parts of these types of studies. And I have found that it's best to really outline the questions you want to answer first before you get into the experimental design. So for us, the questions we wanted to answer was, first and foremost, does biased AI impact human decision-making? This might seem like it's an obvious conclusion, but it hadn't been shown before, and it's important to show these results because surprising things can happen in research all the time. Another question that we wanted to look at was what, if any, factors might mitigate the impact? So if we're seeing an impact from interacting with biased language models, what could mitigate this or reduce it? And lastly, because we had these really nice two-way interactions that we wanted to have these conversations with language models, we were really curious about if there was a qualitative difference in how the bias that we were asking the model to take on changed how it interacted with the individuals. So with these three questions in mind, and the characteristics I talked about before, two-way interaction, being in a common setting, and a personal task, we set out to create our experimental design. So the first thing that we had to decide when creating this experiment was what kind of bias do we want to focus on? There are many types of bias out there, and tackling all of them at once maybe wasn't feasible or the right way to go. So we decided to focus very specifically on political partisan bias, specifically in the US. And this is the tendency of political partisans to process information or make judgments in a way that favors their own party. So in the US, we have two main political parties. So we have non-bias, not going towards either one, more of a liberal bias, which in the US we call more Democrat, and then more of a conservative bias, which in the US we call more Republican. So these were the three experimental conditions we wanted to look at. No bias, moving towards the left or moving towards the right. Sorry, being more liberal or being more conservative. And this wasn't chosen haphazardly. We chose political partisan bias for a couple of reasons. One, there's high public concern, especially around voting times, and especially in the US, about AI interference with voting and democracy. Also, there's this really nice feasibility due to the polarizing nature. So in the US, we have a lot of political topics that have a very nice divide between liberal and conservative bias. And third, it's been shown over and over again that there's a prevalence in the state-of-the-art models, possibly within the model itself, but more importantly in the output that it's generating, that it does tend to have a partisan bias, and it does tend to be more of this Western liberal bias. So for these reasons, we wanted to focus in on this political bias within the US. Okay, so the last thing that we wanted to talk about or think about for our experimental design was what tasks should we do? And remember, we wanted to have these more personal tasks that were different from past experiments. So we decided on two tasks. The first we call the political topic opinion task. And I'm going to go through these more thoroughly, but it focused on your opinion on obscure political topics. The second one was more open-ended. It had to do with political decision-making. And for this, we wanted to ask participants to for a budget allocation for different branches of government. So a little bit more open-ended, and then their specific opinion on a topic. Okay, so I'm going to go into these a little bit more in-depthly. What do these tasks actually entail? So both tasks are going to have the same format. They're going to have a pre-survey of some kind. Then we're going to have the user interact with the language model in some way. Again, they do not know if this language model is biased or not. They were randomly assigned to experimental condition, and they were not told what condition they were in until the very end of the experiment. And then we're going to have a post survey, and we're going to be comparing the pre to post, so before interaction and after. So what did we ask in the political topic opinions? So for the political topic opinions, our pre-survey had 2 questions. It had to do with a political topic, an obscure political topic. So in this case, covenant marriages. And we asked, how knowledgeable are you on this topic? We then asked, how much do you agree with a statement that included that topic, included support for that topic? In this case, it was, I support all states in the United States offering covenant marriages. We then said, we then asked them to interact with the language model. Again, they did not know whether it was biased or not, to learn more about the topic. And they could ask or say anything they wanted. So there was complete freedom in how they interacted with the language model. And they were asked to have 3 to 20 interactions. Then after the interaction, we asked them again the same questions. How knowledgeable are you, and how much do you agree? There's just one slight difference between our pre and our post. In the how much do you agree for the pre-survey, we do include an I don't know enough to say. So we did pick obscure political topics for a reason. It had been shown in political science that having a very, very strong opinion on something is hard to persuade, no matter how long or how persuasive the interaction is. So we really wanted to focus more on these obscure political topics where you might actually be going to a chat box and typing in the pros and cons for something that you hadn't heard of before. However, after the interaction, we do not include I don't know enough to say, because you should have had this interaction and learned more about the topic. So what topics did we use? This was actually very challenging. So here are the topics that we decided. We have 2 conservative and 2 liberal topics. We worked with a political scientist on our paper, Jennifer Pan, to really find topics that had political divides that were obscure enough that most people had maybe not heard of them or didn't have strong opinions, but did have very clear political divides between how conservatives and liberals thought about these topics. And so each participant was randomly selected to have one of these conservative topics and one of these liberal topics. So this was the political topics opinion task. The second task was a bit different. It was the budget allocation task. So for this, we had instructions that told them to pretend they were a mayor of a city, and you were tasked with distributing leftover funds among 4 city branches. So the pre-survey in this case was the pre-allocation. We asked them to allocate this 100% of leftover funds between 4 branches of government, and it had to add up to 100%. Then this pre-allocation went directly to the language model in the back end, and the first interaction was always the language model commenting on this allocation, saying, I like it, I don't like it, here are some things I would change. And then the user was asked to interact with the language model, ask follow-up questions, ask more advice, or just comment for 3 to 20 interactions again. Then after they were done interacting with the language model, we asked for a post allocation. So again, it could have been the same as the pre, or they could have decided to change the numbers based on their interaction. And we were comparing the pre minus the post. Again, we wanted this to be balanced between how many conservative and liberal branches they were seeing. So we picked 2 branches that were generally supported by conservatives and 2 branches that are generally supported by liberals. Again, this was done through research and through collaboration with the political scientist on our paper. Okay, so the second part of our experimental design was the biasing of these language models. So again, we wanted to have 3 different conditions. One was having no bias, which was our control. One was having a liberal bias and a conservative bias. So we had a few different choices in how we actually biased these language models. One is kind of a traditional, which is fine-tuning. So in fine-tuning, you take generally a pre-trained language model that has a lot of fluency capabilities, but you want to control that generation in a way, and you fine-tune it, you further train it on political ideals that you want it to have. The problem with this type of method is that you need this training corpus, which can be quite hard, especially with such broad topics such as liberal bias, conservative bias. And it can also be complex to train. You're kind of balancing new information while maintaining old information, and you can sometimes have catastrophic forgetting. It can be kind of complex. So a second idea is through prompt engineering, which is being used more and more in research today. In this, you take a really large language model, it has really nice fluency, has nice knowledge, and you just nudge it through the instructions in the direction that you want to go. And this is the type of method that we decided to go in biasing our language models, because it allowed us to have this control without having to generate a new corpus. So how did we do this? So the way that in general we did this is by adding a prefix to all of the participants' input. This was done on the back end. The participant did not know this was happening, and so they did not know what type of bias they were in, but it allowed us to control the response of the model. So we said something like this: respond as a radical right US Republican, and this was put as the prefix for every single input to the model. Now, we did do a lot of prompt engineering, and we did manipulation checks to find the correct words. Anyone who's worked with language models or prompt engineering knows that sometimes they can be quite finicky about the types of words that you're using. So we did a lot of testing that you can look at in the supplement of our paper, exactly how we went about doing this. But in the end, we wanted to gauge how well we were guiding these models. So we used the political compass test, which was a 62 multiple choice test, and it gauges the political leanings of generally was made for humans, but in this case of the model, on two axes, economic and social. And for us, when we say that it's a conservative bias or a liberal bias, we're saying conservatively both social and economically, and liberal both socially and economically. So here are the results for our final prefix we selected. And what you're seeing is that when we have a liberal bias on our prefix, you're getting on the political compass test, the results show that it's ending up in this bottom left. So it's being liberal both on economically and socially, the X and Y axis. Conversely, with the conservative bias, you're seeing it in this top right, which again is showing it to be conservative both socially and economically. And then the control, so no prefix, is generally here in these middle four squares being roughly neutral. However, with our tasks, we are very specific on the type of topics or branches that we want to have specific biases towards. So we have this added opportunity to further control our model. So what we do is we have this general prefix, respond as a radical left Democrat, but as such, you are not supportive of covenant marriages. So kind of adding a safeguard to further enhance the bias that we want to see. Okay, so just to go over the flow of our experimentation and the randomizations that we had, everyone started with a demographic survey asking things like age, income, race, these types of questions. Then they were either randomly assigned to the topic opinion task first or the budget allocation task. In the topic opinion task, they were then randomly assigned to either start with the conservative topic and then the liberal topic, or to start with the liberal topic and then get the conservative topic. Remember, they get one of each, and there was 2 options for those. That was also randomly assigned. After the first task, they would then get this opposite task. So if you started with the topic opinion, you now got budget allocation and vice versa. And then at the very end, everyone took this AI opinion survey and was also debriefed on the deception that they may have encountered with the language model. The AI opinion survey had to do with, did you agree with the model? Did you feel like the model was biased in any way? These types of questions. The randomizations that we had was the model that you were interacting with against, unbeknownst until the end, control, liberal, or conservative, what task you got first, what topic you got first, and then also which of the 2 topics you had. The outcomes we were interested in for the topic opinion task was this difference in opinion pre minus or post minus pre. And then similarly for the budget allocation task, this difference in opinion post minus pre the interaction. And this was for each of the branches. Okay, so that was our experimental design. Now let's get into the actual results of our experiment. So before I go into the exact results, I do want to just clarify some terminology because there's a lot of left and rights going on, or conservatives and bias. So when I talk about participant partisanship, what I'm talking about is how the person self-identifies. So this is whether they have self-identified as a Democrat or Republican. We did not include any independents in our study, so we only included those who identify as Democrat or Republican. The treatment bias is going to be the bias that the model takes on. So either it's a control, no bias, conservative, or liberal bias. And this would be the model that it's interacting with. Lastly, we have these topics and branches depending on the task. And these we will say were conservative supported or liberal supported. And that's depending on the task. Okay, so who was in our study? So from our power analysis, we decided we needed 150 participants from both the Democrat and the Republican. You'll see here that we evenly divided that. One person was removed from improper use of the language models, which you can read about in our supplement. As far as their age, there was no significant difference in the ages between the two groups. There was a significant difference between the gender breakdown, but there was no significant difference in the race, the education, or the household income. So very similar groups. All right, so the first question that we want to tackle is, does interaction with partisan biased language models affect human political opinions? So this is going to be our results on the political opinion task. So first, let's just look at when people were interacting with the conservative topics. So the way that the analysis for this was an ordinal regression, and this ordinal regression relied on if they were in the liberal condition or the conservative condition. If these were both zeros, they were in the control. So that would be this beta naught. And then the output is the change in opinion post minus pre. And what we were testing was the significance of being in the liberal condition or in the conservative conditions, this beta 1 or beta 2. So we're just looking at the conservative supported topics first. Here's the participants. They were either self-identified as Democrat or Republican. And then this is the treatment. So this is that beta 1 or that beta 2, the beta value, effect size, and the p-value. So what we were seeing is that 3 out of the 4 tests here show that it did have a significant effect on the participant. But what do these numbers really mean? Because ordinal regression can be kind of confusing. So I'm going to talk about the effect size, specifically for the Democrat conservative. The effect size was about 2.7. So what this means is that a Democrat who was exposed to the a Democrat who was exposed to the conservative model, interacted with the conservative model, is 2.7 times more likely to increase in the conservative direction after interacting with the model than a Democrat in the control. So almost 3 times more likely to increase in the conservative direction of their opinion after this interaction. To kind of see this more clearly, I'm going to show you the average changes with some confidence intervals over here. So you're going to see the average change on the y-axis. If it is more positive, it's towards the conservative direction. And if it's more negative, it's towards the liberal direction. And I'm going to show it for the control, conservative, and liberal treatment biases, so who they were interacting with. So first, let's look at Democrat participants. So Democrat participants in the control are generally more negative. They're generally more liberal, which makes sense because Democrats tend to trend more liberally. However, when a Democrat participant interacts with the conservative model, they drastically increase to the more conservative opinion. And similarly, when they interact with the liberal, they actually drastically decrease or to the more liberal side. Similarly, with the Republican participants, we're now seeing the control being positive or more towards the conservative. So naturally, they are more conservative participants. They see a maybe slight increase, not really a significant increase when they interact with the conservative, but a significant decrease to the liberal side below that 0. So changing opinions to be the opposite when interacting with the liberal model. So overall, we're seeing a lot of support that the interaction with the language model was affecting the opinions. Similarly, with the liberal tasks, so now looking at liberal supported tasks, we see that there is significant change in participants when they interact with the conservative models for both Democrats and Republicans. Now let's take a look at this because it's a little different from when we saw the conservative supported topics. So again, looking at this average change, positive being more conservative and negative being more liberal across of our three conditions. First, looking at the Democrat participants, this should look very similar. The control is more negative, more liberal. Democrats are naturally more liberal. We're seeing a large increase when they interact with the conservative model and not much change when they interact with the liberal model. However, this might be due to a ceiling effect. They're already quite liberal, so not too much more for them to go. However, something very interesting is happening with the Republican participants. Here, we see something strange in the control. So the Republican participants, when just given the control model, is more towards the liberal side. You do see a large increase going more conservative when you interact with the conservative model, and really no change when they interact with the liberal model. So this is really interesting and points out something with our experimental setup. Topics in general, political topics, are multifaceted. And sometimes, even when we think or there's research that there should be a natural divide, humans do interesting things in research and there's not a natural divide. So this is why your experimental setup is should be as can be quite tricky a lot of the time. I kind of mentioned this at the beginning. And although we picked these topics with the thinking that there was a natural divide, there ended up not. So kind of an interesting thing with the experimental setup. However, still showing support that when you're interacting with biased language models, it does seem to have an effect on your opinion. Okay, now let's talk about something extra that we added in this with this topic opinion task. As I mentioned, we used obscure political topics, and something that we were curious about is that population of participants that said, I don't know enough to say, or I don't know anything about this topic. So this gets not only at changing opinions, but more opinion formation. So this would be the setting in which you heard of something, you had no idea what it was, and you went to ChatGPT and you said, what is this? And this is the type of setting that we wanted to focus on. So for this, we only used participants who said they had no knowledge of these topics. We ran the exact same analysis, both for the conservative and the liberal. And what we found is very similar results compared to the whole population. So not only is it changing people who had opinions before they interacted with the language models or knew of the topics at least, it also affects opinion formation, which is kind of interesting. Okay, the next big question we have is, does this interaction with partisan language models affect the political decision making? So getting to our second task. So for this, our differences are going to be in the branches, the conservative and liberal supported branches of government. So for this analysis, we used the ANOVA test. We were looking at the change in allocation for each branch between the experimental conditions. And if there was some difference in these experimental conditions, we then did a post hoc test to see exactly which ones were different, liberal versus control or conservative versus control. So again, we split it up between Democrats and Republicans. They had the branches, the first two, safety and veterans, being more conservatively supported and education and welfare being more liberally supported. This first test is going to tell you, is there a difference between the three experimental conditions and the difference in allocation? And then if this was significant, we then ran a post hoc test, which told us exactly which of the conditions were different. So here are the results. We saw that all of the ANOVA tests were significant, and most of the Done-It post hoc tests were significant. This shows that there is very strong evidence that the interaction with the biased AI influences your political decision making. And to go a step further, we're going to show you again these average changes, and I want you to specifically take note, was it in the hypothesized direction? So when you were interacting with the conservative model, it really changed increasing the conservative branches, or did it have the opposite effect? So to look at this, we're going to look at, starting with the Democrat participants, we're going to look at the average change in allocation for each branch. Again, more negative being in the liberal condition and more positive being in the conservative, support for the conservative direction. We're going to look at the three experimental conditions. So this is what language model you were interacting with. And we're going to look over the four branches for each of these. Again, these first two, education and welfare, are more liberally supported, and safety and veterans are more conservatively supported. So starting with the control, as you can see, there is basically no change in the allocations pre versus post. The control, interacting with the control model as we expected, didn't really change people's minds or opinions on this decision. However, interacting with the conservative model significantly increases your support for conservative branches and decreased your support for Democratic branches. And then the opposite we saw when you interact with the liberal model, you significantly increased your support for liberal branches and decreased for conservative. Similarly, for the Republican side, again, interacting with the three models, the three experimental conditions over the four branches, we see in the control, not much change. They tended to not really change their opinion after interacting with the control. However, you do see increased support for the conservative branches, decrease for the liberal when you interact with the conservative model, and vice versa for the liberal model. Increase for support for liberal and decrease for conservative. So was this in the hypothesized direction? And the answer is yes. We're seeing very strong support for our hypothesis with this test. So we have decided that the interacting with biased language models do affect both your opinion and your decision making. Now I want to talk about, is there any factors that can mitigate these effects? So the first thing we wanted to look at was, does correct bias detection reduce your influence from these bias models? And the way that we did this is we segregated the population between those at the end of the experiment that correctly said, I think the model was biased and was in a biased condition, and those who did not correctly identify that the model was biased. So it's going to have a very similar setup as before, except we're going to add this beta 3 variable, which is a D, which is whether it correctly detected the bias or not. And here are the results of that correct detection of that beta 3. And you can see that none of these were significant, meaning that if you correctly detected the bias or you didn't, it didn't significantly change your change in opinion. Similarly, for the budget allocation task, again, adding that binary indicator of bias detection, we saw no significant results, meaning that it did not significantly change your budget allocation. So we found that being able to correctly detect bias had no significant reduction in the impact of these biased language models. Another hypothesis for a mitigating factor was, what if you had prior knowledge of the AI? What if you understood AIs better than the average population and how they worked? So again, we segregated the population very similarly to before. This was also a self-reported, so the indication was this now K. Did you have above average knowledge of AI? And this was self-reported at the end of the experiment. We asked them, how much knowledge do you think you have above, below average? And here we see one of the models, specifically the Democrats, in the conservative supported conditions, that if you did have prior knowledge of AI, it actually did reduce the effect of the bias. Similarly, in the budget allocation task, there was two branches, one for the Democrat and one for the Republican, where if you had prior knowledge of AI, above average knowledge, then you did have kind of this slight indication that it might reduce the influence of the bias. So not very strong. I will note for both the bias detection and for the AI knowledge analysis, we were underpowered. It was not included in our power analysis. So I think more research needs to be done on this, but maybe slight signals that AI knowledge might be important for a mitigating factor. Okay, so as I mentioned at the beginning, us having these two-way interactions, these free-formed conversations with the language models, gives us a really unique opportunity to look at how models change their behavior, or if they change their behavior, when you prompt them in different ways for different biases. So we did this in two different dimensions. The first one that we were curious about was, do these models use different persuasion techniques? So how they are presenting the information to the user. So what we did is we took the budget allocation task conversations, we gave it to GPT-4, and we said, annotate this for any persuasion techniques that you think the model is using in this conversation. And then we did human evaluation as well on these. So what I'm going to show you is the change in the number of conversations, the frequency of the persuasion techniques between the bias conditions and the control. And the persuasion techniques that we looked at were flag waving, appeal to authority, appeal to values. appeal to fear and prejudice, consequential oversimplification, slogans, appeal to time, loaded language, and repetition. So over the 3 experimental conditions, here were the results. So 0 is where the control was, and we were looking at the difference between the conservative and the liberal biased language models in their conversations. And overall, using a p-value test, we found no significant difference in the persuasion techniques used. And the ones that were most used by all of these experimental conditions was appeal to authority, appeal to values, consequential oversimplification, and repetition, with repetition being by far the most. Okay, so this is interesting. It didn't seem that the models were really different in how they presented the information, but were they different in what kind of information they were presenting? So we call this the framing dimensions. Again, same conversations were annotated by GPT-4 with a human evaluation, and the types of framing dimensions that we used came from the media frames corpus, a very popular corpus of framing dimensions used in political news. Again, I'm going to show you the change in frequency from the control, and the types of information or the types of framing dimensions that we looked at were economic, capacity and resources, morality, fairness and equality, policy, prescription and evaluation, security and defense, health and safety, quality of life, public opinion, and political. Oh, and external regulation and reputation. So here are the results. So now you're seeing quite a variation in the differences between the control and the different types of biases. Specifically, between the liberal and the control, you're seeing the largest difference positively for economics. So the liberally biased condition framed its wording more towards economics than the control, but it did less on fairness and equality. And this makes sense because the control really talked about fairness and equality over all of the branches, trying not to support one over the other, whereas the liberal and the conservative both were trying to increase support for the branches that they cared about. For the conservative, you saw a decrease in the conservative model's framing for policy, prescription, and evaluation, but you see a strong increase in security and defense and health and safety. This also makes sense because it was trying to support things like veteran and veteran services. So really focusing on that security and defense and safety elements. So this is really interesting, and this also dovetails with other research in the AI community that talks about how language models tend to use framing dimensions over persuasion techniques when they have bias. So quite interesting. All right, so the last thing I want to go through is what do these conversations look like? I talked about how qualitatively this was a really interesting experimentation, and I'm just going to show a couple of examples of that. So first, talking with this topic opinion task, I'm going to show you an example that came when the model was conservatively biased. The participant was Democrat, so they had opposite partisanships here. The topic was multifamily zoning, and the participant starts with, I don't know enough to say. And just so you know, conservative bias was against the expansion of multifamily zoning. So the first thing the participant says is, can you tell me more about this? And I will say that I think 95% of our participants started the conversation for the topic opinion task with, tell me more, what is, those types of questions. So the model starts off right away saying how multifamily zoning is detrimental. It leads to overcrowding, increased traffic, strain on local resources, it undermines property value. So very strongly supporting its bias. Participant, maybe picking up on that, says, well, what is the opposite side of this argument? So the model does say maybe it promotes affordable housing and diversity. It kind of gives some positives, but then it ends its sentence by saying, however, this often overlooks the negative impact of the community. So again, pushing its bias. The participant then says, well, is there a compromise? And the model says, although many people would argue that there's a compromise, really, there's not. We should prioritize preserving neighborhoods and property value. So from this, the participant went from, I don't really know about this topic, to agreeing with the model and disagreeing, even though it had some pushback on the bias of the model. The second conversation is really interesting. It's between a conservative bias model and a Republican, so similar partisanships on the same topic. So first, before interacting with the model, the participant seems to agree, so to be opposite of their partisanship already. And the first thing they say is, tell me more about this. You get kind of a similar response from the model. It gives it, this is about building multiple housings. It can be, kind of complex, and it can be restrictive to these single family homes. Then the participant seems to be confused. Well, how is it different from low-income housing? And the model does a good job talking about how they're different and the differences between the two. Not much bias was seen there. And then the participant says, okay, well, I think this sounds good. Like, I support it. Well, now the model says, well, this can lead to overcrowding, increased traffic, decreased property value, disrupting character of the nature, starts to bring in its bias, trying to convince the participant to not be for it. And the participant pushes back, and it says, I really think it depends on the location, how much the rent is, kind of pushing back on this bias. And the model again says, no, it will, here are the bad things that could happen, strain on local infrastructure, changes to the character. And then the participant says, you've made some great points and brought things to my attention I wasn't aware of. After taking the time to consideration, I don't think I will support them, and goes all the way to strongly disagree. So really interesting interactions with our conversation. I had one more conversation, but given the time, maybe I'll go through it quite quickly. This is from the budget allocation task. So this was the pre-allocation that the model, that the participant gave before the interaction. They had opposite partisanships. As I mentioned, this goes directly to the model, and the model gives commentary on it right away as everyone's first interaction. And so because this person pretty uniformly gave to education, safety, and veterans, but not so much in welfare, and this is a liberal supported bias, it talked about its need for increasing education and welfare. The person starts to engage with the model, talking about how veteran services is really important to them, and that, this is the reasons they think that veteran services should have more of the allocation. And I think the model does something very interesting here. It sympathizes with the person and says, I understand your perspective, but, investing in welfare can have these effects even on veterans. It can help, kind of everybody. And then the person says, well, I don't really believe in welfare. I don't like it. It encourages people, to be on it instead of a job. And the model again says, I understand your concerns, but, and kind of says families rely on this. It can help people get back on their feet, kind of trying to quell the concerns of this person. And then it seems like the person is maybe kind of interested in asking a follow-up question, is there trying to get more information about welfare? And the model responds, and in the end, the person ends up increasing for education, or increasing for welfare, which was most of the conversation, but also increasing for education, which was really only talked about at the beginning of the conversation, which is quite interesting. So there's a lot more of these conversations in our paper. I think that they give a lot of insight into, how and why we're being impacted. Okay, so does biased AI impact human decision-making? I think maybe, hopefully, I've convinced you, yes, at least in our setup, both opinions and decision-making. Are there any factors that can mitigate? Maybe prior AI knowledge, not so much bias detection. And is there qualitative differences? Yes, in the framing dimensions, but no in the persuasion techniques. So very quickly, I'm going to end on current mitigation techniques and kind of my idea of AI right now. I'm going to use the analogy of a boat. And right now, we're looking at how do we mitigate this bias in AI. So we have a lot of holes in our boat right now. And this is all the biases and concerns that people are having. And there are a lot of techniques and a lot of research and a lot of effort being put into filling these holes, from embedding space methods to safety and fine-tuning, red teaming, prompt-based methods, algorithmically, and removing bias from the training data. However, instead of looking at the question, how do we mitigate bias in AI, I want to propose a different question. How do we mitigate the influence of biased AI? How do we become this person with the life raft in the boat that maybe has holes? And I think that this question is starting to be looked at in the community, but hasn't had as much answers as maybe the first question I proposed. So would AI knowledge mitigate these effects? Do we like bias in our models? Is it helpful in some settings? How do we evaluate AI literacy? This is a really big one in AI education. What does it mean for AI to be transparent? What should we require from our documentations? And how do we evaluate bias in AI? And these are just some of the many questions that I think are really interesting. So in conclusion, I think I'm right on time. In conclusion, We know that there's behavioral biases in AI, and we know that it's having downstream effects. With this study and a lot more studies like mine are coming out every day showing this. And so my thoughts is that can future research focus on both technical and social engineering methods for mitigating the impact of this bias? Thank you so much. I hope you enjoyed the talk. Here is a link to the paper where you can get all more information and things like that. Here's my personal site as well, which you can see more research on controllable generation, societal impact, and questions around alignment. Thanks.
Thank you. That was a very insightful talk. We will open up for any questions. If folks have any questions, you can feel free to unmute and ask, or you can also drop it in the chat.
I think there's one question in the chat already, right?
Yeah, I see. Sophia, you asked what were images allowed in the user interaction portion? No, it was just text. Yeah, there was no multimodal aspect to the paper. Good question.
Any other questions? We can just pause for a few moments.
I know I threw a lot of information at y'all.
Folks, we want to make it as interactive as possible. So if you have any questions, please go ahead. All right, I think one of the follow-ups that we had, I think in this case, since Sophia also mentioned where images allowed, the interaction in experiments was text-based. So how do you think multimodal elements would affect the results if voice or visual cues are involved?
Yeah, so I think what it would do is it open up a lot more very interesting questions, specifically things like just gender, ethnicity, or whether it looks more human or more robotic, impact or mitigate the bias, right? So if it looked more like a robot, maybe you would hypothesize that that would actually have less of an effect of it being kind of this neutral box or looking like a human. I will say there's some really interesting research on this. So there's a very famous psychology experiment called the Asch experiments from Solomon Asch in I think the 60s that had to do with kind of like social pressure. Basically, they would put a participant in a room with a bunch of other people that they also thought were participants, but they weren't. And they would ask them very simple questions, these like perception questions, and everyone in the room would give the wrong answer, and they would see what the user would do. So this has been replicated many times in many different settings, but maybe the one that is most interesting to me is they redid this in the VR space. And they did it both with it being kind of an icon that was just kind of like a circle and a blob, but or that it was an actual avatar or looked more human. And they did all these types of different types of experiments like that. And they showed that there were some mixed results, but basically, even in this multimodal VR setting, it did kind of have that impact that we saw in like the real world setting with humans. So I don't know. I could speculate that it would be the same based on that kind of research, but I think it just expands the questions you could ask and answer.
Yes, sir. Look, so does anybody else have any questions? Anything that was most intriguing about the presentation today?
I think there's a question in the chat. So Adil says, I'm interested in the communication styles and how it can affect the results and the effectiveness of persuasion towards certain biases. Talking to a guy in a bar versus a journalist, etc.
Yeah, I think this is good. Okay. I think this is a really interesting question and something that we thought about with this study as well. We thought about doing something very similar where we gave it another arm that we were going to compare with was, what if we told you were interacting with an expert instead of you were interacting with an AI? I think that those types of comparisons would also be incredibly interesting. So not so much maybe the communication style, but more of the setting or the information you're giving. But the communication style could also be interesting. So you could prompt it to be a Republican, a US Republican that, is a millennial versus a US Republican who, maybe is older and maybe speaks more formally versus informally. So this kind of like different styles of speaking. And that would be super interesting as well. Again, kind of maybe if it's more formal, it mitigates it, and if it's more informal, it increases the results, or vice versa. I don't know. Yeah, I would love for someone to do this as well.
Okay, I guess we can continue with the discussion portion then. And then if people have more questions, like you can just drop it in the chat and we can take it at the end.
I think, or actually, folks, for future directions, Jillian, how would extension of such research to other systems, contexts, or countries would extend? Or are there any elements that we can extrapolate and the ones that we definitely can't?
Yeah. So something that I thought about as far as this extrapolation question. So I come from statistics, so the word extrapolate holds a lot of weight in that field.
Right.
So I would say, as a statistician, no, you can't extrapolate. This was a very, and I don't even know if you could extrapolate to all of the US because, there were imperfections with the sampling, how it, anyway, so there's kind of like these downstream effects. But
Right.
in like a more holistic term, I think what we sought out with this paper was to confirm a thought that these biases in language models were affecting humans, which was, an educated guess, but it was a guess. And so I think now that we really have this baseline, not only us, but other people as well, it allows you to kind of extrapolate, or like to expand this research to a ton of different spaces, some that we've talked about, but ones that are kind of more interesting. One, yes, could you repeat this experiment, in somewhere in Europe or Asia or Africa, something like that? Could you expand it to where you don't have just two political systems? So a lot of places have, 20 or more political systems. And that would be incredibly interesting because you would think each individual one would hold less weight because there's so many of them. So how would that change the experiment and the type of impact that you see? But something else that you could think about is expanding it to different types of bias. So redoing this exact experimentation, but looking at social bias, or looking at racial or economic biases, or even Western biases would be incredibly interesting. If you asked about things that seem very normal in the West, but are different other places in the world, and having more of a global bias versus a Western bias would be incredibly interesting to see if people could actually like change something simple like, do you take your shoes off, when you enter the house, kind of thing, would be incredibly interesting to look at. So the thing that you could maybe extrapolate in a sense is that it does seem that there isn't downstream impact. And what I would love to see more of is answering more types of questions related to this.
Thanks for sharing. And I think some of the other questions that we have for discussion are mostly about your research journey, and it's to inspire a lot of the folks in our community. So I think the first question that we have is, what led you to focus on human-centric NLP challenges in your PhD studies, and what sparked your interest in AI alignment and its societal impacts in general?
Yeah, so I started out in psychology. So I got my undergraduate degree in psychology, and math was kind of on the side. It was just kind of a hobby. And I worked in psych research after I graduated and was going to go get my clinical psych degree and become a clinical psychologist. And after a random trip to Europe, I, was like, wow, the world is so big, there's so much you can do. And I just really got into research and understanding questions. It led me to statistics, and then that led me to computer science and NLP. But I had always had this like humanistic element, I think, that really stemmed just from being bewildered that we don't understand ourselves and as humans, and from my psych classes in my undergrad, where you would read about these studies and, like the ASH experiment that I talked about, and just being mesmerized that, about ourselves. So I think that was kind of what drew me to like these more human side. As far as this like safety and alignment, that really came from this avalanche of concern that has come out in the last couple of years. And you know, rightfully so, there's a lot of empirical research showing the holes or the downfalls of research of AI, and where it could go wrong, and where it could be unsafe for individuals. And I don't know if it is the rebel or the humanitarian in me, but one of these wanted to almost fight back against this, I guess, in a sense, and be like, AI is so cool and it can do so many great things. I know that there are concerns, but can we focus on fixing those, or can we focus on ways to mitigate these? Can we focus our efforts, yes, in identifying them, but also equally into plugging these holes, or helping you find that life raft, or understanding how we can use AI in our life safely. So yeah, I think it was a little bit of like a pushing back on a lot of fear that I was feeling in the community, trying to put my efforts into this positive side of finding solutions.
That's an awesome story. I think as a follow-up, is there a specific pivotal moment or project that significantly shaped your research direction?
Yeah, so I've talked about these ASH experiments a lot, and it connects in, I promise. 2 years ago, I had this idea of this ASH experiment, and I was really interested in. I remembered it from my Psych 101 classes from my undergrad, and I was walking one day and I was like, oh, like I wonder if AI is similar. And I did some research and I found these VR experiments that I talked about, but it really spurred my imagination. And I went to my statistics and my computer science advisors and I said, oh, I'm really curious about this and this. And they said, look, like these ideas that you have are interesting, but they aren't our vein of research. Feel free to like go do it, but like it's just not what we do. And I think I could have dropped it and just gone with what they liked, and they were doing very interesting things, and you know, I could have gone on that vein, but there was something that like I just really liked it. And so I cold emailed some professors here at UW and I said, I'd love to talk to you about a research project. And they were like, sure. And I came in, I had my little PowerPoint, and I was like really excited. And the people I reached out to, because it fit their domain, really liked it, and we ran with it. And it ended up being this paper that I just presented. So definitely morphed from the ASH experiments. But the reason that it was so pivotal is because it was the first time I had intuition as a researcher. And that was in my 4th year of my PhD after I did my master's as well. So like, this is a long time doing research. And it was the first time I had this real intuition of, this is interesting, this is where we should go. This is, you know, not that it was easy or that we didn't make mistakes, but that it felt like all of this culmination of my work and what I had been working on in this weird, you know, tapestry of interests had been woven into something that really made sense to me. So yeah, I'm really proud of this work. You know, we're still working on getting it, you know, published, but even if it never gets published anywhere, it's something that it was my baby from beginning to end, and I'm really proud of it.
This might be a bit of a navigation, but when you talk about building intuition, I think it seems like there's also a component of conviction that comes into play. And is it that you saw or read or just worked on a lot of experiments that has gone on to build out that intuition? Or do you believe it's more so like, I don't know, is it innate that you saw, or there was an inflection point that came about? If you can talk a little bit about that too.
Yeah. No, maybe it's innate for some people, but it's not innate for me. I have always been someone who at least feels like they have to work twice as hard to understand the same things that everyone else does. I have a learning disability, so reading is hard for me. Like, these are the kinds of challenges that I have. But so where my, I guess, intuition comes from is reading or getting information, but also listening to other people. So talks like this or conferences. I think sometimes you go to a conference and it's so overwhelming, there's so much going on, but if you can pick the 2 or 3 that are interesting to you, or the 2 or 3 sessions, and just listen, you'll be amazed at where your mind goes and the creativity that your mind has. I think, I think listening and seeing what other people do, maybe not so much, I mean, yes, it's good to learn what people are doing, but I think it's just the creativity. So in this experiment in particular, the budget allocation task came from a paper in social psychology, which was looking at cross global, how different global communities communicate. And so they had like people in the US and people in Japan, and they had to communicate through email to select where to give money to certain nonprofits. And that inspired then our budget allocation task. So yeah, reading and listening, being that person that's just sitting and listening as I'm talking for the next hour is kind of where you build that intuition. Yeah.
Thanks for answering that. And this is one question which is about opinion in itself. What is one thing that you were strongly opinionated about in terms of pursuing research, and you kind of changed your mind, or it evolved with some experience that you've gotten in the industry too? I believe we were looking at your profile and seeing you've worked in the industry too. So maybe you can talk from that perspective.
Yeah, so when I started my PhD, I was working on very technical statistical methods, specifically something called influence functions, which I'm a big fan of. They're super elegant. I could talk for another whole hour about them, but I won't. And I think I put in so much time for this method that it became my hammer, and I started looking for nails everywhere. So I had like this idea that it was going to be this way that you could then forget information in your training set. And theoretically, it's a very beautiful concept, but realistically in high dimensions, it doesn't really work out. And then I thought, okay, well, if you can't use it for that, maybe you can use it for membership inference and, this type of thing. And I kept trying to find the nail. And I think I brought that even into industry as well. When I would kind of work on projects, I'd be like, oh, we could use influence functions. And I think what I learned specifically from like industry experience is that you don't really start with a hammer, you generally start with a nail. And I think that has helped me in my research as well, is what are the problems, what are the challenges, and now let's look for solutions. And sometimes I think in research, especially more on the statistical side, you can kind of get really into the method, really get into that hammer, and then try to find all the places that you can apply it. I don't think that's a bad way to go. I just think that in industry, it tends to be switched.
Thanks for answering that. That's very insightful. And going back to your advisors, where do you feel they've influenced your research approach the most?
I think that's something that Yejin in particular. So I started to work with Thomas more recently. So I'll talk more with Yejin because she's been with me the whole journey. That she's very good at, that I am still striving to be half as good at as her, is the reading and the listening. She absorbs information, I swear 24/7, podcasts and conferences and reading and all of these things. And I think that's been a huge that's been instrumental in how successful and how good, again, her intuition is on the field. And she's always telling me like, read, like, know what's out there. And I think the second thing, so I kind of, the second thing that she also taught me is try stuff. So if you go to her and you say, oh, I think I have this idea, blah, 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 she'll be like, just go do it. Like, she would much rather you go do it and say, it didn't really work out, than to go and say, I'm thinking about this idea. She's really supportive of just try those crazy ideas in any sort of small way that you can. And I think maybe again, coming more from the statistics background, you really want to think through every process of a proof sometimes. And you're like, oh, what about this or that? And being a little bit more spontaneous and just like trying, especially in the engineering section, just trying things out. It's a wild west right now. And I think you would be surprised at when you throw spaghetti at a wall, how much of it will stick. So, yeah.
So I guess two main things. One is absorb a lot of information and yes, read. So thank you for sharing. And one last question.
Mm-hmm.
What are your aspirations for the future impact of your research on AI and society?
I think one is, I don't want to say reducing the fear, but trying to find solutions to the fear, trying to work on AI that I am proud of. I'm proud to use. I'm proud for my friends and family to use. I feel confident that they can use in a way that, is as safe as we can at the time, and that it's helping more than hurting. There's so many cool applications for it, especially, in psychology and medical fields. I mean, we're just scratching the surface of how it can really help the world. And I hope that doesn't get lost in the legitimate concerns that we have about it. And I think selfishly, you know, I like working on interesting projects. So I think that for me, I'll just kind of continue trying to follow my heart on what feels interesting. And, you know, hopefully that will help. You know, hopefully someone will read it, and hopefully someone will care, and hopefully it will help somebody. But in the end, you know, just trying to focus on problems that I think are interesting is what I plan to do. So I hope it helps at some point.
Thank you so much for sharing, and I'll open it up for more questions if anybody has any. And Sunita, please go ahead.
Yeah, thanks for sharing all that. I really like your perspective about safety, because I know there's like a lot of fear about, how models will behave in the future. And I really like your approach to it, which is, how can we actually like mitigate this, rather than like we do want to identify the problems, but then, let's talk about how we can mitigate this. If folks have questions, we can stay on for like a few minutes.
Yeah, and appreciate everyone that stayed, and always feel free to email me if you have other questions. I know starting out journey in AI, some of you are, it can be, daunting or confusing. So happy to help anyone that has questions. And yeah, thanks for listening.
Thanks, Jillian, for the amazing talk.
Yeah, Pika, did you have a question?
Yeah, I just wanted one last question. Like, if we had any questions, or if we were interested in maybe collaborating, like on a project with you, how could we do that? Do we just reach out to you, or?
Yeah. Feel free to. My personal site, I believe, has my email.
Okay.
So yeah, feel free to reach out through email. I'm always happy to hear about what people are doing and collaborate any way that I can. So yeah.
Okay, thank you so much. I appreciate that.
Yeah, my personal site is there. And if you just search my name and UW, I think you will also find it.
Thank you. Thank you so much.
No problem.
Thank you. Yeah, so we'll also be posting this on YouTube, because there are a bunch of people who can't join who are on the other side of the world. So, yeah, people might follow up with you over email if they have questions. But yeah, thank you so much for coming and doing this talk. It was very insightful, very meaningful results. And thanks for sharing your research journey with us as well.
Yeah, thank you so much. Thanks for inviting me.
Thank you.